vary from universe to universe or within a single universe. See, remember, we talked about how we keep finding these particles in particle physics with all these different numbers for their mass, charge, etc. And it's like, is this random, or are we just kind of collecting upon, are we seeing a snapshot of this that is like this here in this universe, and in a different universe maybe they have a different number? Maybe the mass of the electron in a different universe is different. Isn't that crazy? Oh my gosh. And maybe that universe didn't make it, and we made it. Because if the mass of the electron was remember how if the mass of the electron was bigger, we might have been in, actually, let me think about that. If the mass of the electron had been bigger, let me think about that. I think I remember how the fine balance of the electromagnetic force, the weak nuclear force, and the strong force were all sort of on a fine balanced situation. I bet, you know what? Now I'm liking the multiverse theory more, because there might be universes where things just died, There might be a universe where the mass of these particles or the charge or the something is different. Oh! And then those universes didn't make it. Maybe they didn't evolve like ours. Aw, poor things. The remarkable fact. Okay, so we have to find them by observation. These numbers, for example, the numbers I kind of talked about right now. It may be that one day we shall discover a complete unified theory that predicts them all. Maybe that's why the unified theory is so difficult, because you kind of have to almost explain other universes too, potentially. Wasn't there something about dark matter being like, other universes getting, oh no, oh my gosh, maybe other universes can explain dark matter. Oh, you know what I mean? Maybe other universe, like dark matter could be sort of like other universes coming and going in and out of existence, maybe. And that could be why we have dark matter. I don't know. Okay, we'll see. I don't know. We'll see what he says. I'm sure he's going to say something about that. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. So that's the fine balance, more of the fine balance situation that we're talking about. Is that the fine tuning, as you said, to make us happen is sort of remarkable. For example, if the electric charge, this is it. So it might not be the mass, but it might be the electric charge. The mass could be important too. Like the mass of the electron in a different universe could literally be different, but the electric charge, I think, is an interesting one. So for example, if the electric charge of the electron had only been slightly different, stars either would have been unable to burn hydrogen and helium, or else they would not have exploded. Of course, there might be other forms of intelligent life, not dreamed of even by writers of science fiction, that did not require the light of a star like the sun or the heavier chemical elements that are made in stars and are flung back into space when the stars explode. Nevertheless, it seems clear that there are relatively few ranges of values for the numbers that would allow the development of any form of intelligent life. Most sets of values would give rise to universes that, although they might be very beautiful, would contain no one able to wonder at that beauty. One can take this either as evidence of a divine purpose in creation and the choice of the laws of science